Hello, welcome to this lecture series on electronic properties of materials. This is lecture number 4. In this lecture, I am going to discuss about Drude'S parameters. Very specifically, the two parameters Vf and relaxation time tau. Okay, what is Vf? Vf is called as drift velocity, also called average final velocity of the electron, final average velocity of electron. It is also sometimes called as saturation velocity of the electron, saturation velocity under the electric field strength epsilon. And what is tau? Tau is nothing but relaxation time of the electron, relaxation time, right? Also called mean time between two successive collisions. Clear? Now, how to calculate these quantities? It's very simple. To calculate tau, okay, you can make use of the conductivity formula, right? So you know very well, conductivity formula sigma is equal to, from Drude'S equation, sigma is equal to number of free electrons per unit volume into square of the charge on the electron into relaxation time tau divided by mass of the electron m. If you rearrange this expression, you can write tau is equal to sigma into m by number of free electrons per unit volume into E square. Okay, so if you know the value of conductivity of the metal, and if you know number of free electrons per unit volume for the metal, you can calculate the value of tau by making use of this formula. Okay, then how to calculate the drift velocity? We have direct relation between drift velocity and tau, which we discussed already in the last lecture. Okay, I am going to give you the only final expression. Okay, so drift velocity, also called final average velocity, also called saturation velocity, which can be calculated using the formula E into epsilon into tau by mass of the electron m. By making use of using the formula, you can calculate the value of tau. Clear? Now, before going to see how to calculate the tau and Vf, right, by making use of these formulas, I will give some of the values which is already reported. Okay, some of the values of tau which is already reported for few metals. Okay, just right here. So metals, and the value of tau at 290 Kelvin. Let me write here. Tau is relaxation time. I'm going to give the value at 290 Kelvin and in 10 power 14 second values. Okay, in 10 power 14 second values. So for the metal copper, the value found to be 2.7 into 10 to the power 14 seconds. Then for metal silver, the value found to be 4 into 10 to the power 14 seconds. Okay, these are all reported tau values. I'm sorry, this is 10 power minus 14. I'm sorry. Yeah, 10 power minus 14 seconds, right? So 2.7 into 10 power minus 14. For silver, it is 4 into 10 power minus 14. And for gold, the value is 3 into 10 power minus 14. And for aluminium, the reported value is 0.8 into 10 power minus 14 at 290 Kelvin. Remember, relaxation time depends on temperature. Clear? So here I have given the values of tau for few metals. Okay, we can also calculate the value of tau by measuring the conductivity of the metal. Okay, yes. How to proceed? I'll do one or two problems so that you will get some clarity on this part. Let me take problem 1 here. Yeah. Yes. see this problem. Just go through that. The conductivity of sodium metal is given 2.17 into 10 power 7 Siemens meter inverse. It is given in SI unit. Okay, so watch this carefully. Calculate the relaxation time and drift velocity at 300 Kelvin under the electric field strength of 200 volt per meter. Okay, so what are the data given? So solution. What is the data given? Conductivity is given. We use the symbol sigma for conductivity, which is 2.17 into 10 to the power 7 Siemens meter inverse. Then electric field strength is given, epsilon is equal to 200 volt per meter. Both the values are given in SI unit. Okay, now first we'll calculate relaxation time, then we'll calculate drift velocity. Okay, how to calculate relaxation time? Relaxation time tau is how to do that. Tau is equal to, I have given the formula. By making use of Drude'S equation, you can write tau is equal to sigma into m by nf into e square. Okay, what's the value of sigma given? Sigma is 2.17 into 10 to the power 7 Siemens meter inverse. Mass of the electron, you know very well, 9.1 into 10 power minus 31 kg. I am substituting all the values in SI unit. Number of free electron per unit volume. This data is not given here, but usually they will provide. Otherwise, they will provide the conductivity. They will provide the density value. So if density value is given, you can very easily calculate the value of the value of NF. So what is NF here? NF is nothing but number of free electron per unit volume. And I think in the lecture 2 I gave all these values. Okay, number of free electrons per cc. For sodium metal, the value is 2.65 into 10 to the power 22. Okay, so I'll take this value directly from the table. Okay, so in the examination they will provide. Okay, so number of free electrons per unit volume for sodium metal is 2.65 into 10 to the power 22 centimeter power minus 3. Per centimeter cube we have this many electrons, but we have these values in SI unit, but this is in centimeter cube, so convert this into meter cube. So you can write this as 2.65 into 10 to the power 28 meter power minus 3. To convert centimeter power minus 3 into meter power minus 3, you just multiply this value by 10 power 6. So you'll get 10 power 28. Now substitute this value here. So 2.65 into 10 to the power 28 into E square. The charge on each electron is 1.602 into 10 power minus 19 coulomb. Okay, and take the square. Right. So let me calculate this value. I'll use calculator. Just a minute. Yeah. 2.17 into 9.1. 2.17 into 9.1 equal to this, divided by 2.65 equal to this, divided by 1.602, divide again by 1.602. So we get a value 2.99035. Let me check once again whether it is correct or not. 2.17 into 9.1 equal to this, divided by 2.65 equal to this, divided by 1.602. Again divide the value by 1.602. Yeah, I am getting the value exactly 2.9035 into 10 to the power. See, here we have plus 7, here we have minus 31, so this will become 10 power minus 26. No, 24, correct? 10 power 7. Okay, 10 power 7, and here we have 10 power minus 31, so this becomes 10 power minus 24, and here we have 10 power minus 38 in the denominator. See, square is there, so 10 power minus 38, this is 10 power plus 28, so this becomes 10 power minus 10. Okay, in the denominator. If we bring it to the numerator, it becomes 10 power plus 10. 10 power plus 10. So this will give me 10 power minus 14 roughly. Okay, so the answer is 2.9035 into 10 to the power minus 14 seconds. We are calculating relaxation time. Since we are substituting the values, all the values in SI unit, we will get directly in second unit. Okay, so relaxation time is 2.9035 into 10 power minus 14 seconds for this given data. Clear? Now, how to calculate the drift velocity? Yes, let me do it in the next page. Drift velocity of the electron. Second point. How to calculate the drift velocity, also called saturation velocity, also called final average velocity of the electron. Okay, and I have given the formula already. Vf is equal to E into epsilon into tau over mass of the electron m. Okay, and you know very well the charge on each electron is 1.602 into 10 power minus 19 coulomb, and electric field strength is given. Okay, the value is 200 volt per meter, so I'll substitute the value as such, 200 volt per meter, into tau, relaxation time just now we calculated, 2.9035 into 10 power minus 14, 2.9035 into 10 power minus 14 seconds, divided by mass of the electron 9.1 into 10 power minus 31 kg. Okay, yeah, right now we'll assume that mass of the electron inside the metal, okay, is nothing but the free mass of electron. But later we are going to see that the mass of electron inside the metal is not the same value as given here. Okay, it is called effective mass. We'll discuss about effective mass of electron as we go along, right? Now what we get here, let me simplify this. Yeah, so how to calculate this value? 1.602 into 200 into 2.9035 equal to this divided by 9.1. I am getting a value 102.2287 into 10 to the power. So here we have minus 19 minus 14. So if you add, you will get 10 power minus 33. Okay, 19 plus 4, 23 plus 33. If I bring this 10 power minus 31 in the numerator, I will get 10 power plus 31. So what we get is 102.2287 into 10 power minus 2 meter per second. You will get the velocity in, because we are substituting the values in SI unit, so you will get the velocity also in SI unit. Clear? 10 power minus 2, you can also simplify this, 1.0222. Okay, I'll just write 4 digits after decimal point, meter per second. Okay, so this is the drift velocity of the electron, right, under the electric field strength 200 volt per meter for the relaxation time of 2.9035 into 10 power minus 14 seconds. This is how you should calculate the drift velocity. Clear? Now I'll take one more problem and I'll show you how to do this. Take another problem here. Yeah. Calculate drift velocity of an electron which is subjected to an electric field of 20 volt per meter. Relaxation time is given. So this problem is quite simple. It's quite simple because relaxation time is given directly. Right? How to calculate? You know very well, drift velocity. So we have to write the data actually. So let me write directly. So drift velocity. formula for drift velocity is given as Vf equal to E into epsilon into tau by mass of the electron m. Clear? E value is 1.602, charge on each electron 1.602 into 10 power minus 19 coulomb, into electric field strength is 20 volt per meter, into tau value is given 10 power minus 14, divided by mass of the electron 9.1 into 10 power minus 31 kg. Okay, so if we substitute these values, and if I simplify the, or if I calculate the quantities, what we get, let me do it here, 1.602 into 20 equal to divided by 9.1. I am getting a value 3.5208 into 10 to the power. Here we have minus 19, minus 14, you will get minus 33. If 10 power minus 31 comes to the numerator, you will get 10 power plus 31. So you will get 10 power minus 2 seconds. Correct? Meter per second, yeah. Meter per second. So this is the value of velocity, but just go through the question carefully. They are asking velocity in centimeter per second unit. But the answer that we gave here is in meter per second. To convert meter into centimeter, you have to divide by 100. So 3.5208 into 10 power minus 2. If you convert meter into centimeter, you have to multiply by 100. Okay, you will get centimeter per second. So 10 power minus 2, 10 power plus 2 cancel each other. You will get 3.5208 centimeters per second. This is the drift velocity of the electron, okay, for this given data. Clear? Take note. This is how we should calculate the drift velocity and relaxation time. Remember, drift velocity and relaxation time both depends on temperature, okay, as well as the electric field strength. Okay, yeah, I stop here. We'll discuss about the thermal conductivity of the metal in the forthcoming lectures. Okay, yeah, I stop here. Thank you for listening.